Hello and welcome to Math Lessons with Linda. Today's topic is how to solve a single inequality. So this is what an inequality looks like. I'll write the problem and then I'll read it, what it would sound like if I just said it out loud. So I have x minus 8 is less than negative 11. So this looks very much like an equation would look, except I have the less than symbol rather than the equal to sign. The steps for solving inequalities are mostly the same as solving an equation. So for this one, it's pretty straightforward. I'm going to try to isolate the x, and that means that on both sides, I'm going to add an 8 to get these terms to cancel out. So I keep my x, I keep my less than symbol, and I add together negative 11 and positive 8, so I get negative 3. So if we're just solving an inequality, it looks like this, and that means x is less than negative 3. A lot of times you're going to be asked to graph this on a number line to represent what all the solutions look like. So the number that I'm really wanting to make sure is on my number line that I can see is negative 3. So I'm going to put that here. We know that 0 would be somewhere up here, and then my numbers get to be bigger negatives down here. So these are just for some context of where I am on the number line. My inequality says that x has to be less than negative 3. Notice it's not less than or equal to. So when I have just a less than symbol, I'm going to go to negative 3, and I'm going to put what we call an open circle. So it doesn't include the negative 3. That's what the open circle means. But I need to shade or show where all the other values are for x that are less than negative 3. So numbers get smaller than negative 3 as they go to the left. So as the numbers look like they're getting bigger, but they're bigger negatives, right? That means the number is actually getting littler. So here's my shaded solution for x is less than negative 3, everything here to the left. Now, some teachers will also ask you to do what's called interval notation, and that's another way you can represent what the solution set is rather than this. So as we keep going to the left on the number line, we would go all the way eventually to negative infinity. So on my interval, I'm going to represent the negative infinity with just a parenthesis. That means that it doesn't stop. It's not like a cutoff point. It would keep going as far as negative infinity could go. And that's on the left. On the right-hand side, I'm going to show, well, where do I want to stop on the number line? And I want to stop at negative 3. I again am going to use a parenthesis because it doesn't include the negative 3. So this is how I would write a solution set using interval notation for an inequality. So let's try one more problem with an inequality. So negative 10, x is greater than or equal to 50. I want to find all the values for x that satisfy this inequality. Now, I chose this because something special happens when you have a negative coefficient with your variable. And we're going to talk about that just in a moment. Now, if I'm solving this like I would an equation, what I normally would do is I would divide by a negative 10, right, to get this to cancel out, and I would have my x left over. Over here, I would do 50 divided by negative 10. I would get negative 5. But when it's an inequality and you divide or multiply by a negative, you change the direction of the inequality. So this reads greater than or equal to. So what I'm going to do is I'm going to change it to less than or equal to. If I don't do that and I keep it the same way, a negative, if I have a negative and multiply it by a negative, that's how I would get my positive back. But if I didn't change the direction of the inequality, then my arrow, when I graph it, would be going the wrong way. We'll see what happens when we look at this on a number line. So again, I want to do -5 as my marker on here. So here's -5, the 0 would be here, and then again, I'd be like, down here is -15. So if I have an equal to sign now with my less than, I'm going to put a circle here at -5, but I'm going to color that in because this time my solution set is going to include this -5, and I still want to go to the left and shade that in. These are all of my solutions. So let's see what happens if I didn't flip my inequality, if I had left it a greater than and had shaded this way. Let's choose an easy number like 0, okay? So if I do 0 times -10, I get 0. Would 0 be greater than or equal to 50? It would be false. 0 is not bigger than 50. So I know that my answers can't be over here or anywhere in this direction. But if I choose a number like -10, let's say, that's one of the numbers that would be in here. -10 times my other -10, would that be greater than or equal to 50? I would get 100, and it's positive. Is greater than or equal to 50? Sure, 100 is greater than or equal to 50. So I know that I shaded in the right direction this time. Now, if I'm doing interval notation, again, I would do -infinity, and I would go up to -5, but this time I'm going to use a bracket because I include the -5 as part of my solution, and that's where it stops on my number line. So these are a couple of examples of how I solve an inequality and graph it on a number line and use interval notation.